Hello class, so today we'll be doing video assessment number 49 from week 2, which reads as follows. The average density of a fish is about 1080 kilograms per meter cubed. To keep it from sinking, a fish increases its volume by inflating an inner air bladder known as a swim bladder with air. By what percentage must the fish increase its volume to be neutrally buoyant in fresh water? The density of air at 20 degrees Celsius is 1.19 kilograms per meter cubed, right? So if we take a look back at our question, we can actually reflect on the fact that we're basically being asked for volume and density. And thankfully to us, we have an equation that deals with just so. And that goes as follows. It is rho is equal to m over v, where rho is equal to the density, m is mass, and v is volume, correct? So look at us, right? Onto something. Now, however, we have to understand from our question that this little sexy guy right here stays floating by the fact that he increases his inner bladder with air, right? So this sexy guy needs air to float, meaning that this system here not only depends on the mass of the fish, but also the mass of air. So we can modify this equation to look something like so. Rho of the body, let's say the system, right, is equal to the mass of fish plus mass of air, right? Because we're also taking into account the mass of air, or just air in general, over the volume of fish plus volume of A, which will be the volume of air, right? However, we just have a little issue, and that is that within our question here, we're not really care about mass. Nor does the question or us care about mass. But again, thankfully for us, if we take a look at this equation here, we know that mass is equal to rho times volume, right? So we can therefore continue to modify this equation to look different where we take out the mass, right? So we can make rho of the body or the system is equal to rho of fish times volume of fish plus rho of air times volume of air all over the volume of the fish plus the volume of air, right? So now we have an appropriate equation to know how to keep this sexy guy floating, right? So now let's take once more another look at our question, and understand that it's basically asking for a relation between the volume of the fish by inflating an inner bladder, right? So we can say that a relation between volume of the fish inflating her inner bladder, and represent that by BA, so the volume of air, in regards to the volume of the fish, right? That will keep him floaty, this guy right here. And since we're dealing with volume and density, well, this somehow has to be related to density of the body, right? Or just any density of this sexy guy. So we can take a look back at this equation that we have derived and try to format it in the terms of V of air times V of fish. So we can do that by moving the denominator to the other side. So we can have the volume of the body times volume of fish, volume of air is equal to volume of fish, density plus. So we have arrived to this equation. Now we can distribute the density in this side right here to get something along the lines of this. Right? But now we can actually move things around to have with each other like terms, right? Because we're trying to balance this equation out. So we would have something like, so we would have the body, the density of body, Okay, so we have arrived to this equation, and we can see that because we move things around, we have a common denominator on this on both sides, which is volume, right? So we can take that out. We can have volume is equal to the density minus the density is equal to volume F of density minus density. Okay, so now we can actually move like terms together, and we will get something along the lines of V of F is equal to over V of A, and then we'll get this over that like so. Okay, look at us. We reached something. We reached what we were looking for. This rate of change that is correlated to the density of the fish. So now we've proved mathematically that the change in density of the fish is equally demonstrated on the change in volume, right? So this will keep it from sinking. So if we plug in our values, which we've been told up here, the only thing that we haven't told is the density of water, but we know from lab that that is equal to 1,000 kilograms per meter cubed. And if we plug in everything to our equation and put that into our handy dandy calculator, as I've done before here, then we can get the fact that is equal to 0.08, which translates to 8%. So 8% of the fish has to be submerged in order for this. It needs to increase its body by 8%, its volume by 8% in order for him to float.